In this entire class, we will discuss about reduction. Removal of oxygen from the metal oxide. Metal oxide to get crude metal in the molten state. So, removal of oxygen from the metal oxide. In roasting and calcination, we obtain the metal oxide. See, you got the lead oxide and you got iron oxide. Okay, see, from lead sulfide you got lead oxide. See, this sulfide ore is converted to oxide ore. Are you clear about that one? Now in this process what we are doing, you are removing this oxygen. Present in the metal oxide. This phenomena is known as what we call it reduction. Or in 8th class you also studied that. You can write anyone as the definition. That is addition of electrons. Or another one, addition of hydrogen. In this metallurgy, we avoid this addition of hydrogen because it is not there. We don't discuss about that. We only discuss how to remove the oxygen from the metal oxide or how we are adding electrons to the metal oxide. Are you clear about that one? So addition of electrons is nothing but reduction, or removal of oxygen from the metal oxide is also considered as reduction. Are you clear? So what are the different techniques or different methods present in reduction? The first one is chemical reduction. What is that? Chemical reduction. I will discuss one by one. First you write down. Second one, self-reduction. What is that? Self-reduction. Third one, reduction by displacement. The fourth one is, here I am writing, the fourth one is electrolytic reduction. What is that? Electrolytic reduction. So, these are the four methods we are going to discuss in this reduction process. One is the chemical reduction. Other one is the self-reduction. The third one is the reduction by displacement. The fourth one is the electrolytic reduction. Then when do we adapt these techniques? Okay. For all the metals, do we adapt these four techniques? No, it is not possible. Okay. So depending on the reactivity of the metals. Okay, I told you what is reactivity. Then next, how we arrange the metals in the reactivity series. Okay, so we considered three things to decide the reactivity. First one is reaction of the metals with oxygen. The second one is the reaction of the metals with water. The third one is the reaction of the metals with acids. Okay, dilute acids particularly. So depending on these three, see this one, reactivity series. Here I am writing. How we decided? By considering reaction of the metals with oxygen. Second one is reaction of the metals with water. The third one is with acids or dilute acids. Dilute acids. Okay. So all the metals, for example, you take the case of potassium, sodium, calcium, magnesium, aluminum. All these metals react with oxygen to form metal oxide. To form metal oxide. For example, sodium oxide, CaO, calcium oxide, magnesium oxide, and aluminum oxide, Al2O3. Okay. So all these metals, for example, you take the case of potassium. Potassium readily reacts with oxygen, vigorously reacts with oxygen. Are you clear? Highly reactive. And sodium is also highly reactive. Calcium is also highly reactive. As you move from left to right, the reactivity goes on decreasing. These are all highly reactive. No doubt in it. But when compared among these 5 metals, see this one, the reactivity goes on decreasing. So these 5 metals are placed in highly reactive metals. Highly reactive metals. So in the reactivity series, what do you mean by reactivity series? When the metals are arranged in the descending order, that is decreasing order of their reactivity. What they have considered for the reactivity? Reaction with oxygen, reaction with water, and reaction with dilute acids. Are you clear? First you make a note of this thing. Now listen to me. Here I am writing metals, reaction with and product. Here I have written potassium, sodium, calcium, magnesium, aluminum. They react with oxygen. What is the product? Metal oxide. Metal oxide. So these are considered as, next, come to the next point, water. What is the product you will get? Metal hydroxide. Metal hydroxide plus hydrogen is liberated. Hydrogen gas. Okay. For example, you take the case of sodium, any metal, not only any metal, plus water, that is I am giving here sodium hydroxide plus hydrogen gas is liberated. See, this potassium, sodium, calcium, they react with the cold water. Remember that. What are they? Potassium, sodium and calcium. They react with the cold water and liberate hydrogen. Next, come to the next case. Reaction with dilute acids. See this one. When they react with dilute acids, you take the case of same metals, potassium, sodium, calcium, magnesium, aluminum. Okay, they readily react with dilute acids, metals plus dilute acids. What is the product formed? Salt, no, plus hydrogen. Okay, are you clear about that one? You take anything, if you take magnesium, it reacts with HCl and forms magnesium chloride MgCl2 plus hydrogen. Okay. Next, potassium, sodium and calcium, as soon as they are dropped in the acid, as soon as they touch the acid surface, they readily reacts and explosive reaction takes place. Explosive reaction takes place. Are you clear about that one? So they are readily reactive with acids. Are you clear? Dilute acids. Next one, in the case of, you take the case of next one. Here I am writing zinc, iron, next lead, copper. These metals. See this one. Zinc, iron, lead and copper, they also react with oxygen, but they are not readily reactive. They are not readily reactive. Are you clear about that one? So when you heat these metals, they react with oxygen. They react with oxygen and they give metal oxides. They give metal oxides. They give metal oxides. Are you clear? Zinc oxide, iron oxide, lead oxide, cuprous oxide. Are you clear? Cu2O, lead oxide, PbO, FeO, ZnO. Are you clear? So when you compare to these, they are moderately reactive. So these are placed in moderately reactive group. Moderately reactive. Okay? Are you clear? Next, they also react with acids. You take the case of zinc. Zinc reacts with dilute acids and give zinc chloride. This is a salt plus hydrogen. Are you clear? Next, magnesium. It also reacts MgCl2 plus hydrogen. In all the cases, they react with acids. Try to understand. As soon as they touch the acid surface, they are explosive in nature, and hydrogen gas is immediately generated, liberated, and a lot of tremendous heat is liberated. That heat, due to that heat, the gas hydrogen explosion takes place. Are you clear about that one? You understand that? Next, but this one, when compared to these metals, they are slowly reactive. Next, among these four metals also, see this one. Zinc is very reactive when compared with iron. Iron is very reactive compared with lead. Lead is very reactive with copper. So when you are moving left to right, from left to right, what is happening? The reactivity goes on decreasing. Are you clear about that one? Okay. So these are the things they considered to decide the reactivity series. Are you clear about that too? So all the metals, known metals, are kept like this: highly reactive, next moderately reactive, low reactive. Highly reactive. What are the examples for that one?
Potassium, sodium, calcium, magnesium.
Okay. Lead and next, low reactive. What are that? Mercury, platinum, gold. Next here, see this one, silver, platinum, gold. Okay, are you clear? So when the metals are arranged in the decreasing order of the reactivity, what is reactivity series? Give an example. So reactivity series is a series in which the metals are arranged in the descending order, of their reactivity, What they have considered to decide the reactivity? They considered reaction of metals with oxygen, reaction of metals with water, and reaction of metals with what is the dilute acids. Are you clear? In the case of water and in the case of dilute acids, they liberate hydrogen. Next, one more thing you have to remember. You take the case of iron, okay, see this one, and magnesium. Okay, these metals do not react with cold water or hot water. They do not react with cold water or hot water. They react with steam. These metals react with steam and form, what is that? Metal hydroxides plus hydrogen. Try to understand here. This potassium, sodium, calcium reacts with cold water also and liberate hydrogen. Whereas this one, magnesium, aluminum and iron, they react with steam only. And produce metal hydroxide and hydrogen. Are you clear? Do you understand? So what is happening? The reactivity from left to right goes on decreasing. Are you clear? Do you understand the concept? Next one, you take the case of oxygen and you take the case of all these things. These three are considered to decide the reactivity series. Okay, what is reactivity series? Tell me. Listen to me. What is reactivity series? A series of metals arranged in the decreasing order of their reactivity. What is the criteria for deciding reactivity series? Reaction with oxygen, reaction with water and reaction with dilute acids. These three things they have considered to decide the reactivity series. Are you clear? In tomorrow's class we will discuss different techniques of reduction. Okay, depending on this reactivity series, we have to choose the right method. Okay, are you clear? Right.